A very good afternoon. Today's I'm here to give my seminar on input, output and device management. Myself Amandep Kaur from GPC Khunimajra. Let's start with the device management. Device management is nothing but the thing how the technology changes with each other. Means there is a time when we use the paper storage media and now we uses the optical disk storage. So it is a great change between these. When there is a time when we write everything on the papers, registers, maintain the ledgers, etc. But nowadays we just type on the computer, make a word file and save it. And how easy it is and how convenient it is to update the file, to change the file, to maintain the file, etc. So this is the device management, that how we manage our devices between each other so that the work can be done efficiently, conveniently, etc. So here you see in this box, you see the first we use the paper storage media, like we write everything on the papers. The documentation is the everything is written with the pen and paper. But then there comes the magnetic tape storage. Then we can store our data on a magnetic tapes. Then the evolution of magnetic disks arrived, and then nowadays very easy optical disks are there, which is in the no minute you can write the data, burn the disk, rewritable disk, read only disk, with so many options that you are feasible with you. So we are going to discuss the topics today are system devices, sequential access storage medias, direct access storage medias, components of input output subsystems, communication among devices, that how the communication being done between the devices, and the management of these input output requests, means how the requests are handled, which requests are to be attempt first, which are request is to be attempt then after. So first is device management. It tracks the status of each device, such as what are the devices such as printers, scanners, tape drives, hard disks, to note that which device is currently ready for allocation. That today we have the multitasking, multi-programming is going there. So as we have the multitasking, multiple tasks are executed at the same time. So each task, maybe one task require only the scanner, one type require only the printer, but it can also be the uh, option that the two tasks require the printer at the same time. So to which task we are allocating the printer first is the problem. That's why we need the device management. The operating system allocates the required device to the selected process. Means it is the duty of the operating system to allocate the device to the process which have the request for that. And the operating system uses the various algorithms to decide that which process should be given the control of the device and for how long this control should be given. Means which device to choose, for what duration of the time that device can use the allocated device, is the all the duty of the operating system to allocate the time and the priority to which device we should allow the uh, priority first. So the system devices have some of the important facts which we will discuss here today, like differences among the system peripherals devices are a function of characteristics of devices and how well they are managed by the device managers. Means the life of the devices, the efficiency of the devices is also the responsibility of the device manager. That in which way we are using the devices so that the life of these devices should be increased. And the most important difference among devices is the speed and the degree of the shareability. Means what is the speed of the device? is very much important in the for the, very much important for the operating system to decide how the devices are to be used, to which device we should have the more priority than other. And the degree of the shareability is the two operations can use the one device at a time. Like printer can be used by the two applications at the same time, because uh, the whichever gives this command for the printing, the printer will execute that and the things will be done. But if both the processes need the scanner at the same time, which will not be possible, so it is the degree of shareability, that which process need the which of the devices, either that device can be shared or not. By minimizing the variance among devices, a system overall efficiency can be dramatically provided. So, how these, if the device has the capability that they can be shared or not, it will depend upon that. So, before going to the further detail, that first one should know the what type of devices we are using in today's technology. The devices and the peripherals that are internal or external to the computer can be allocated to the process in the following three manners. Means we broadly categorize our devices into the three categories. The one is dedicated devices, second is shared devices, and the third is virtual devices. Dedicated devices are those devices which are only dedicated to the particular operation, particular task. They are not used by they are dedicated devices are those devices, they are the property of only the one of the tasks that only one can use that. And the shared devices are those devices which can be used by many of the applications. And the third is virtual devices. Virtual devices are those devices which are not actually exist, but we are using them remotely. Means somehow we are using the scanner, somehow we are using the printer, which are not actually present with our system, but they are remotely present somewhere. So, the dedicated devices are the devices that are assigned to only one job at a time and serves the job for the entire time till it's active. Means these are such devices till they are in the active state, they can only use them. For example, the tape drives, printers, plotters, these demand this kind of allocation schemes because it would be awkward to share. But it has some disadvantages too, that it must be allocated to a single user for the duration of the job execution. Might be job takes some more time to execute. In that duration of the period, that device is busy is and the efficiency of that device will be decreased, and it can be a quite inefficient, especially when the device is not 100% of time. Means that device is not utilized during the execution until the 100%, but it is busy or it is acquired by one of the process and will used only for some period, will not used for the 100% of the time. Now the shared devices. As the name suggested, the shared device is the assigned to several processes, means those devices which can be used by many of the processes. For example, disk pad, that is direct access storage device that can be shared by several processes at the same time by interleaving their request. The interleaving must be carefully controlled by the device manager. Interleaving is the process in which we can allocate the time of the shared devices between the processes, that which process can use which of the device for what duration. All conflicts must be resolved based upon predetermined policies to decide which request will be handled first. Then comes the virtual devices. Virtual devices are the combination of both the dedicated devices that have been transformed to the shared devices. For example, printers are converted into shareable device through a spooling program that reroutes all print requests to a disk. That printer is a dedicated device, but we can make it a shareable device by the process known as spooling. So, output sent to printer for printing only when all the job output is complete and printer is ready for the printout entire document. Because the disks are shareable devices, this technique can convert one printer into several virtual printers, thus improving both its performance and use. Then comes the input output devices that we all know what are the input output devices, but input devices are the devices used to supply input to the computer. It is the first phase of the data processing process. So, there are variety of devices in this category which we said this is the input device. As we all know, keyboard, mouse, we all know, we all using it, that it help us to input our data to the computer. Here are some examples of the input device. The very first example is keyboard. Keyboard is the most common and popular input device used to supply input to the computer. It is used to key in the characters by typing them. A 104 key keyboard is the most common and it contains the following keys. The keyboard is a device through which we can convert or input our data to the computer. And the keys of the keyboard are categorized into the four following categories. The first is the numeric key. Numeric key are the keys which contain the numeric data like 1 to 10. These are the numeric key. Then comes the character data. These are the keys which have the alphabets A to Z, a big big A's and the small a to Z. Then comes the special key. Special keys are like the special symbols like hyphen, underscore, caps, tab, shift, control, backspace, control, delete, home, page up, page down, etc. These all are the arrow keys, up, down, left, right. So, these are the special purpose keys. Then comes the function keys. Function keys are the nothing but the keys in which the desired function is already executed like F1, F2, F3 up to F12. Then we all know, we all see, we all are using in our day-to-day life is the mouse. Mouse is another popular input device generally used in the graphical user interface system in which we interact with the computer through pictures. Like it is the pointing device. Everything which is given on the screen, you just click on that and that become your input. A mouse is a pointing device used to supply input through representation called cursor. Basically, this device contains 1, 2, 3 buttons such as having its specific function and a ball at a base which on a movement send input to the computer and results in a cursor movement. So, the ball in the mouse is used to move the cursor on your screen and give its input to the computer. So, keyboard we all know, it is the most common and popular input device used to supply input to the computer. It is used to key in the character by typing them. A 104 keys keyboard is the most common and it contains the following key, that is numeric, character, special and the function keys. Then comes the microphone. As we all know, we heard is the microphone are the one of the following one of the growing days today a most important use device for inputting voice. So how we input our voice? It is the one of the way in which we can record our voice and it translate the analog voice signal into the computer and understandable the digital form. So it's a very important input device which take our voice as input and convert into the digital form. Then comes the smart card reader. A smart card reader is a device that is used to decode the data stored on the magnetic stripes of the smart card. So, which you see the barcoded, we said the barcoded, the magnetic stripes. These are the such device. Suppose you go for the shopping and here you give your card and make your payments. So, some devices there which read your card, which read your bank, which read your account, which read your password, etc. so that you can pay the amount at the same moment. So, these are the device smart card reader which reads the smart data cards. Then here you see the light pen. As you all know, we in the phones we basically use, it is a type of pointing device, same as the mouse. It is also a pointing device that is used to choose a displayed menu on screen for a program. The light pen does not emit light, rather it reacts to the light through a photosensitive detector at its base. So, there is a one of the detector at its base through which it detects the writing material. Then comes the scanner. As we all know, one page we just scan and it comes to your computer screen. Scanner are the one of the most important or commonly used input device. They are used to transfer printed or handmade picture or drawing into the computers. There are broad variety of scanners available today, in which we have the many of the option that whether it convert it to the Acrobat files, JPG file, PNG file, etc. Here is the digital cameras. Here we see a smile on a face, then it clicks. So, camera is a device that stores images digitally rather than recording them on a film. These are the latest type of cameras which use magnetic or semiconductor technology to store the picture. Then comes the touch screen. Touch screen is a device that can take input with a finger touch and it uses infrared beams and ultrasonic waves. Here you see me touch, here you write, you just need to only touch the that portion and you can write anything. So, it is the touch screen is a device that take a finger as a touch. So, these all are the input devices. Now, we will discuss the one by one the output devices. Output device or electronic or electromechanical equipment connected to a computer are used to transfer data out of the computer in a form of text, images, sounds or other media. So, there are two types of output formats such as hard copy and soft copy. A soft copy output device is the first is the computer monitor. The term monitor is often used synonymously with the computer screen or display. The monitor displays the computer user interface and open programs, allowing the user to interact with the computer, typically using the keyboard and mouse. So, monitors are of three different types. The one is CRT, that is cathode ray tube, then LCD liquid crystal display, then LED, that is light emitting diode. Then comes the hard copy display. A hard copy is a printed copy of the information from the computer, sometimes referred to as a printout. We said a printout, take the printout. A hard copy is also so called because it exists as a physical object. Then come the printers. As we all see, to take the hard copy we need the printer. There are basically two categories of the printer on their mode of operation. The one is impact printer and the character printer, or we can say the non-impact printer. Dot matrix printer is a printer that represents each character as a pattern of dots from a dot matrix. So it makes a small pattern in the digital format like 8 format, so that we can visualize what is the soft data on a paper. The next category is line printer. A line printer is a high speed printer capable of printing an entire line at one time. A fast line printer can print as many as 3000 lines per minute. The disadvantage of this line printer are that they can print graphics. They print quality is low and they are very noisy. So they can print the graphics, but the quality is not so much superior. Quality is very low. So the two types of line printer are there, drum printer and the chain printer. The next category of printers are the non-impact printer. The most modern printer are called the non-impact printer since they do not operate by striking a print head against a ink ribbon. The two common of type of non-impact printers include the inkjet printer, which sprays small drop of inks into each page, and the laser printer, which the roll ink into the paper using a cylindrical drum. The non-impact printer are generally quieter and they require less maintenance than impact printers since they don't physically strike a ribbon against a paper. Of course, as we all know, the modern printer can still find other ways not to work properly. Then comes the storage media. A computer storage device is any type of hardware that stores data. The most common type of storage device which nearly all computers have is the hard drive. The computer's primary hard drive stores the operating system, applications and the files and folders for the user of the computer. While the hard drive is the most ubiquitous of all the storage devices, several other types of are common as well. Flash memory devices such as USB, keychain drives and iPod Nanos are the most popular ways to store the data in a small mobile format. The other type of flash memory such as compact flash and the SD cards. Then comes our secondary memory. A computer storage device is any type of hardware that store data. The most common type of storage device which nearly all computers have is the hard drive. The computer's primary hard drive stores the operating system, applications and files and folders for the uses of the computer. Basically what we do in the secondary memory, we make the partitions like a C, D, E, and in the C we kept all our booting files, and in the D we keep our data which is necessarily required to us. And the type of secondary memory devices are hard disk, pen drive, data card, floppy disk, compact disk and digital versatile disk. So first of all we will discuss the disk and the disk drive. A disk drive is randomly addressable and rewritable storage device. The term can be broadly interpreted to include optical device, and in the earlier times the floppy drives. However, in popular usage it has come to remain mainly to hard disk drive, that is HDD. Basically in the older fashions, older times, we basically use the floppy disk, floppy drives to store our data, but nowadays even we cannot see them, they not come to the market, they not come anywhere. So these floppies are the old series, but basically we use that in the older versions in the I think last 10 after in the last 10 year we skip their usage, but the in that 90s or 80s you can say we use that. The disk drives can either be housed internally within a computer or housed in a separate box that is external to the computer. They are found in the PCs, servers, laptops, and storage arrays. For example, they work by rotating very rapidly around a head or heads, which read and write data. They differ from solid state drivers, that are SSDs, which have no moving parts and offer greater performance but also cost more and generally offer less capacity. Then the types of secondary memory. There are basically four types of secondary memories. That secondary memory devices fall into the four main categories. These are the magnetic tapes, magnetic disk, optical storage, and the solid state storage. We will discuss these four storage one by one in detail. The first comes the magnetic tape. A magnetic tape is a sequential storage medium used for data collection, backup and archiving. Like videotape, computer tapes is made of flexible plastic with one side coated with a ferromagnetic material. The tapes were originally open reels but are superseded by cartridge and cassettes of many sizes and shapes. Tapes has been more economical than disk for archival of data, but that is changing. The disk capacities have increased enormously. If tapes are stored for the duration, they must be periodically recopied or the tight collide magnetic surfaces may be contaminate each other. Here you see how this data on a magnetic tape is worked. That is, data is recorded on 8 parallel tracks that run length of the tape. Here you see there are 8 tapes and the data is run parallel to each other, and the 9 track holds priority bits. We set the priority bit used for routing error checking. Number of characters that can be recorded per inch is determined by the density of the tape. Then comes the storing records on magnetic tape. It can store records individually or grouped into blocks. If individually, each record is separated by a space to indicate its starting and ending places. But if blocks, then entire block is preceded by space and followed by a space, but individual records are stored sequentially within the box. For this we have two types. The one is IRG and the other is IBP. IRG stands for inter-record gap. Inter-record gap is a gap between records about ½ inch long. Regardless of the sizes of the records, it separate. So interblock gap is the gap between the blocks of records still ½ inch long. This blocking has some advantages and disadvantages. So pros and cons of blocking are: fewer input-output operations are needed because a single read command can move an entire block, the physical record that includes several logical records, into main memory. Less tape is wasted because size of the physical record exceeds size of the gap. Overhead and software routines are needed for blocking, deblocking and record keeping. Buffer space may be wasted if you need only one logical record but must read an entire block to get it. Then comes the transfer rates and speed. The block size set to take advantage of the transfer rate. So transfer rate is the density of the tape multiplied by the tape transport speed, that is speed and the density of the tape is if multiplied, that gives us the transfer rate. If transfer speed is 200 inch per second at 1600 bpi, a total of 320 000 bytes can be transferred in 1 second. There theoretically the optimal speed of a block is 3,20,000 bytes, but its buffer must be equivalent. Then comes the magnetic tape access time vary widely. So here are some benchmarks that maximum access time should be it should be a 2.5 minute, and the average access time is 1.25 minute, and the sequential access is the 3 millisecond only. So variability makes magnetic tape a poor medium for routing